Namaskar, my name is Dr. Sridhar Patra. I'm a principal scientist, Hydrology and Division, ICAR-Indian Soil and Water Conservation, Dehradun. So, in this lecture, I'm going to discuss trenching in non-arable land for soil and water conservation. So, in this lecture, we will cover these questions. What are the benefits of trenching? What are the different types of trenching? Where should trenches be dug? What are the site stability of different types of trenches, and how to design different trenches. So, let's see what are the main objectives of trenching. The objective is to obstruct the flow of water and store it. This results in meaningful to conservation of soil and reduce soil erosion. More population of surface water into the ground could result in recharge of groundwater because of more opportunity time to these trenches. Improvement of soil moisture locally, and this also reduces fast loss because you are accumulating the runoff of within, and the peak of runoff is reduced and the development over a period of time into the higher rate of the state. And this also reduces seepage of structures downstream, and also increasing extra and the base root stream flows. So these are the objectives of trenching. There are basically two types of trenches: continuous contour trench and staggered contour trench. So here that we can see that the break in continuous contour trench and the gap between two trenches in staggered contour trench. So these two types of trenches have their own suitability for different types of flow and rainfall. And if we see the site suitability of different trenches, the contour trenches, also called continuous contour trenches, these trenches are made where the already go to medium, that is up to 1000 mm annually, and the slopes are less than 6%. Practically, it can be dug up to 10%. In case of staggered contour trenches, they rainfall more than 1000 mm annually, and slopes are higher than maybe 10 to 50%. They can, however, be dug up to the slope of about 60%, only where the slope is stable. Staggered contour trenches should not be dug where the slopes are higher as they get triggered. This the particular schematic diagram shows equates the two trenches to some of the characteristics of the trench. This is the runoff on the surface, through surface, and you can see the horizontal interval between the two trenches, the vertical interval between the two trenches, and the trenches as well are graphic to the east. So to calculate, basically to design the trenches, you need to know the horizontal interval between the two trenches, that is the distance between the two trenches. So there is cross-section area of the trench where the expected runoff that we are going to store. So how it came? So if you multiply the horizontal interval with the length of the trench, so that is the total amount of volume of water that is going to be produced, and that will be stored in the trench. And if we multiply the cross-section area of the trench and the length of the trench, we get the total volume. So if we cancel L and L both sides, we get HI is equal to A by T. For continuous contour trench, the following formula may be used for working of the horizontal spacing, assuming the trench to be rectangular. Horizontal interval is equal to the cross-sectional area is going to be, that is width of trench into depth of trench, which is A divided by 100 into Q. 100 is equal to convert HI into meter. But in case of staggered contour trenches, with the graph, HI will be calculated by A upon 100 Q to 1 plus X by N, where X is the gap between two trenches and N is the length of the trench. So the vertical stretching between the trench is determined by the equation, that is S like 100 multiplied by horizontal interval. So in this way, we calculate the horizontal interval and vertical interval for continuous contour trench and staggered contour. Ultimately, calculate the total volume of earthwork that is expected for a particular project site that trenching is to be done. We have to calculate the trench per hectare. It's 10,000 upon HI for continuous contour trench, and in case of staggered contour trench, we should multiply this 10,000 upon HI multiplied by a fraction, that is L upon L plus X, because that is a fraction in sense of E leg, because there is a gap between two trenches. So ultimately, the trench volume then meter is equal to trench length or hectare multiplied by cross section area of the trench. So in this case, if you know the quotient volume, that is the total life of the system, you can calculate the total cost by multiplying the total offer and the indeed price per cubic meter of So thank you. This was the small presentation about currency. Now